Okay, today we're going to talk about when and when you should not use the product rule. At times you'll see functions like this where you'll have a single term on the outside and then a small binomial or trinomial term multiplied by it. So we do have two factors here. We do have two functions that we can multiply, use the product rule for, but it's not necessary and it makes things more complicated than it needs to be. If we just distribute this single term and break this up, we end up with a much simpler function that we can take the derivative of. So when I start here, I distribute this first term, which is x cubed times 2x, which is going to give me 2x to the fourth. And then you have x cubed times a positive 1, which gives you a positive x cubed. And then you have a really simple derivative to take. You just have to use the power rule from here on. So you should end up here with 8x cubed plus 3x squared as your derivative. Now, you could have done the product rule. It just would have taken a long time. You would have had a lot more operations to deal with. So if you have a single term multiplied by something else that's very similar to it, just go ahead, multiply it out, and move on from there. Now, there are times when you do have to use the product rule, and that's when you have functions that don't kind of go together. Like this function up here, you've got an x cubed and a 2x plus 1. There's nothing that's not connected there very well. So you'll see this type of function a lot, and most of the time it's going to be some of the more special terms like e, natural log. So we're just going to throw both of these together. So we've got e to the negative 2x power times the natural log of x. In this problem, we can't just easily link these together. We can't simplify it anymore. So we do have to think of this as a product rule required problem. So we need to identify our two functions. So we've got e to the negative 2x, and we have the natural log of x. So I'm going to call this function g. I'm going to call this function h. Excuse me. G, h. Okay. Well, if we look at g here, we get e to the negative 2x, and g prime, if you remember your rule for finding the derivative of e to some power, we multiply out front by the derivative of the exponent. So pretty simple. The derivative of this exponent is negative 2, and then we just have e to the negative 2x still there. When we move on to the natural log of x, or excuse me, we move on to h of x, sorry. This is the natural log of x, and then we have h prime of x. This is another definition that you need to know. The derivative of the natural log of x is going to be 1 over x, which represents the derivative of x over itself. So now that we have everything mapped out, we can go ahead and do our product rule. So when we do that, we start off with g of x, which is e to the negative 2x. We then multiply by h prime of x, which is 1 over x. We then always add to that. We're going to add the derivative of g, which is negative 2 e to the negative 2x. And then we're going to multiply that by h of x, which is the natural log of x. So you can see how these things link together. G will link with h prime, and h prime, or h will link with g prime, excuse me, sorry. So that's how we put those together. Now, we're going to want to simplify this just a little bit more. You should notice that you have an e to the 2x in both terms. So we should go ahead and factor that out. It's going to make a cleaner function that's a little bit easier to understand and eventually take the derivative of. So we're going to factor that part out. You're going to get e to the negative 2x out front. You have to decide what remaining factors are left when we factor that out. Well, this is just e to the negative 2x times 1 over x. Since we're factoring out an e to the negative 2x, we just have to write what's left over, which is just going to be 1 over x. We then look at our next term here. Negative 2e to the negative 2x times the natural log of x. Well, what terms are left if we factor out an e to the negative 2x? Well, you have a negative 2 and you have a natural log of x. So those two are going to go together to make our last term here. So you get negative 2 times the natural log of x. Now, so this problem is fully simplified. There's no way to get this answer without doing the product rule. So just hopefully over time you'll gain the sight where you know when to save yourself some time. Like in this last example, you didn't have to go through that whole process. You could have just broken it apart from the beginning and saved yourself a lot of steps. So look for, again, the single term out front that kind of links together with the other terms on the inside. All x's, all t's, or whatever variable it is. That's perfect. And then in another sense, when two functions don't match up and are being multiplied, then you have to go ahead and do the product rule. There's no way around it.